How do you identify the growth, decay factor, rate, and initial value from a function? This is for section 11-8 out of your textbooks, and this is on exponential growth and decay. That title should be at the top of your paper, and go ahead and set up your notes to take notes from this video. Here's an example of how your notes should be set up to take notes from this video. There is only one video title, and this is it. There's no video title 2 or 3. Make sure you complete your notes, write your section and title up top, and then do your summary at the end, which should be 3 to 4 sentences in length. Okay, here is exponential functions. We're going to call this day 1 because we're really going to dive into functions. We've been discussing them and playing around with them, and now we're really going to go ahead and get into them. So in this lesson, you'll be able to identify exponential growth and decay functions. That means you'll be able to tell whether it's growth or decay based on the graph and the equation. Then you'll also be able to identify the growth decay factor, rate, and initial value from an equation. Any quantity that grows or decays by a fixed percent at regular intervals is said to have exponential growth or exponential decay. So here are two examples of exponential growth and decay graphs. Here's one and here's the other. Try to guess which one would be growth and which one would be decay. Well, exponential growth would be this type of graph. That's because if you look at these x values, the more values for x we plug in, the greater we are getting for our y values. Therefore, we are increasing for this graph. So we call it, when we're increasing, we call that exponential growth. And if you look to the graph on the right, is an example of exponential decay. As we plug in these x values into our graph, the y values seem to decrease in value. And so if this is a decreasing graph. And for a decreasing graph, you will have exponential decay. So right away from the graph, you can tell if you are growing exponentially or decaying exponentially. Okay, let's go ahead and graph the following. I've already done my graph, but I'd like you to pause the video, write down these two equations, draw a graph, and then go ahead and graph it yourself using a table, and then go ahead and see if you get the same graph as me. Sorry if this is a little bit off right there, but just imagine that it goes through all those dots. So here's a graph of 2 to the x with the multiplication of 1 in the front. And here's a graph of 3 to the x with a multiplication of 2 in the front. And I want you to think about, what do you notice about both graphs? Well, let's take a look. First of all, both graphs are increasing. As you read from left to right, they're increasing on the graph. So that means that they are exponential growth. They both have a boundary line of x equals 0 right here. Y equals 0. Boundary line of y equals 0. Notice they never cross that, so that helps with the range. And notice that the first number, this 1, is on the y-intercept. And the first number here, this 2, is on the y-intercept. That gives you a hint of how you can graph exponential equations that look like these two. Okay, this time I haven't drawn the graphs first, so go ahead and pause the video, write down your equations, and then try to graph them on your own. And then when you're ready to check your work, you can follow along with me. Okay, I'll assume that you have graphed these two functions, and now you can check your work. And let's go ahead and answer the question at the bottom of the screen. What do you notice about both graphs? Well, while looking at both graphs, we notice that both graphs are decreasing. Oops, I want to write decreasing. Notice that if you read from left to right, they are decreasing on the graph, going down. Also, they both have a boundary line of y equals 0, which helps with our range. This is the boundary line right here. Right here, notice the graph gets very close to that line but never crosses it. That's the asymptote that we discussed in class. And notice that this first number here, 1, is the y-intercept here, and this number 2 is the y-intercept there. But take a look at the inside numbers versus the other two graphs we looked at in their inside numbers. Okay, now looking back at your graphs, let's talk about the comparison of equation 1 and 2 and the comparison of equations 3 and 4. What we can notice is that in equations 1 and 2, the equations had numbers bigger than 1 in the parentheses. Notice that these numbers have are bigger than 1 in the parentheses. We have 2 and 3. And then look at the second equation. Notice that this number is less than 1. It's 1/2. This number is also less than 1. It's just 0.4. And that has an influence on the different graphs that we have seen. So now we can draw a conclusion from the graphs we saw and the comparison of the numbers. Go ahead and write all this information down, and then when you're ready to follow along with me, you can go ahead and resume the video. This is for exponential growth. Exponential growth is represented by this equation, y equals ab to the x power, and instead of y, we are going to write f of x. Okay, it's going to be f of x equals a times b to the x power. This is for when a is greater than 0, so that means it is a number bigger than 0. Or excuse me, a is greater than 0, so it's going to be, can be anything greater than 0, and b is greater than 1. So we have exponential growth when b is greater than 1. Make sure you underline that part. The graph will be increasing or growing in this sense. So for this example here, each time x is increased, so every time I plug in an x value, each time x is increased by 1, okay, it's increased by a factor of 2. So this really helps us to know what is being increased by a factor of. Notice how this number is greater than 1. In contrast, we also have exponential decay. And so exponential decay has the same type of form of a function, exponential function, y equals a times b to the x power. However, we're not going to write y, we're going to put f of x, okay? And this is still when a is greater than 0, so a always has to be greater than 0. But this time b is between 0 and 1. So b is a decimal or a fractional answer. And the graph will be decreasing or decaying in this case, which is why it's exponential decay. So for this example here, each time x is increased by 1, y decreases to half of its previous value. So each time x is increased by 1, that's what that 1 means. Y decreases to half of its previous value. So this sentence really explains what this exponential function is, and we're going to have to do that for some examples that we're going to do in class. So be prepared to use this type of sentence. Each time x is increased by 1, y decreases to half of its previous value. Okay, now it's your turn to give 2 examples. Give me 2 examples of an exponential growth and exponential decay. And we're going to be able to share out in class the following day. So create 2 examples of exponential growth and 2 examples of exponential decay, and you will win a prize for sharing out your answer with the class. So extra credit opportunity here. So here's a quick recap. Remember, when you have your b value is greater than 1, your graph will be increasing or growing. And when your b value is between 0 and 1, it's a fraction or a decimal, that means that the graph will be decreasing or decaying. So now that we understand how to read the exponential function, let's go and identify some parts. We're going to identify each part of the exponential function for growth and decay functions. Go ahead and write everything you see on the screen and resume when you're ready to follow along with me. The general equation for an exponential growth function is y equals a times b to x, where, now remember, we're not going to write y, we're going to put f of x instead. And a is your initial value. A is your initial value. B is your exponential growth, going a little bit too fast. So a is the initial value that you're going to start with. That's why it's the y-intercept. If b is greater than 0, you have exponential growth. Okay, so the first thing you look for your initial value, then you look to see if you're having growth or decay. So this is growth. Then b is a growth factor. So that number in the parentheses is called our growth factor. And if we need to know our growth rate, the growth rate is going to be 1 plus r. Oh, excuse me, b will be 1 plus r. And since b is given to us, we're actually going to transform this equation. We're going to solve for rate. So rate is going to be b minus 1. So once you have your b, you just subtract 1, and that's going to give you your rate. Okay, let's go ahead and recap again. A is your initial value. If b is greater than 1, you have exponential growth. Your growth factor is inside the parentheses, and your growth rate is going to be that number inside the parentheses minus 1. That will give you your growth rate. The general equation from exponential function, decay function, is y equals a times b to the x power. And remember, we're not going to write y, instead we're going to write f of x. A is still your initial value, just like exponential growth. The same thing for exponential decay. If your growth factor, if your decay factor in this case is between 0 and 1, that means it's a fraction or decimal, you're going to have exponential decay. Then your decay factor is what's inside the parentheses. And your rate is going to be, your decay rate, it's b equals 1 minus r. Or if you're trying to solve for the rate, you would have, if you solve for rate, let's go ahead and subtract 1 over. It would be r equals 1 minus b. So your rate, once you have your b, you would just take 1 minus b, and that would give you your rate. Your decay factor. So 1 minus your decay factor would give you your rate. Okay, let's go ahead and recap. Remember, your initial value is a on the outside of the parentheses. If you're between 0 and 1, you have exponential decay. What's inside the parentheses is your decay factor. And your decay rate, if you needed to know your decay rate, you would do 1 minus b, what's inside the parentheses, and that would give you your decay rate. Okay, this information on both the last two slides will be important for us to practice our next couple of examples. Okay, go ahead and write everything you see on the screen here. There we go. Everything you see on the screen, go ahead and write it down. And then try to identify the growth or decay, whether it's growth or decay, the initial value, and then the growth or decay factor or growth or decay rate. And then when you're ready to check your answers and see if you're correct, go ahead and resume the video. Okay, here are the answers. Hopefully you got it right. Let's take a look. So our decay, was it growth or decay? Well, inside the parentheses, this number is greater than 1, therefore it's growth. The initial value is on the outside, which is 3, so this is our y-intercept. I'm going to put that in parentheses. You should do the same. This is our y-intercept for our graph. Then our decay, this is growth factor, so our growth factor is 1.8. It's inside the parentheses. And then our growth rate is going to be 1 minus b. B is 1.8, so 1 minus 1.8 is 0.8, and that's our growth rate. Okay, go ahead and see if you can get the correct answer for this problem. Identify if it's growth or decay, give the initial value, the growth or decay factor, and the growth or decay rate. You don't need to write down the instructions a second time, but definitely you want to write down the example function. Okay, here are the solutions. Hopefully you were correct. Let's go ahead and review. This is going to be growth since we are greater than 1. The initial value is on the outside of the parentheses. Our growth factor is inside the parentheses, which is 1.04. And our growth rate is going to be 1 minus 1.04, which just gives us 0.04. All this information can help us with graphing as well. Okay, go ahead and try this example. This is not example 5, it's example 3. Okay, go ahead and try this example on your own, and then resume when you're ready to check your work. Okay, here are the solution. Hopefully you were correct. Let's go ahead and review. This is going to be a decay function because this number here is going to be less than 1. And notice that there is not inside parentheses, but it is the base for the exponent x. This is a special case where the initial value is not here. It's just an invisible 1 right here. So our initial value is 1. Our decay factor is 0.3. And our decay rate has to be 1 minus 0.3, which gives us 0.7. If you try to do 0.3 minus 1, you would have got a negative number. So it's really simple to decide whether or not you subtract it from 1 or subtract 1 from it. For decay, you subtract it from 1. Okay, let's try looking at a real-world example and see if we can identify the necessary components. That would be the initial value, growth or decay factor, and then the growth or decay rate. So let's take a look. Selena's starting salary for her new marketing management job, and it is $32,000. She calculates her projected salary for the next 5 years by using this function. $32,000 is what she's going to start at, and this is going to be her rate. So now let's go ahead and identify whether this is growth or decay. Will her value of money increase or decrease over the 5 years? Her initial value, her factor, and her rate. Okay, hopefully you were correct in your answers. Let's go ahead and check to see. Let's go to review what we have here. So looking at this exponential function, we realize it is growth because because the number inside the parentheses is greater than 1. Her initial value, what she started at, is her starting salary, which is $32,000. Her growth factor is 1.12. So that's what she can use to plug in different X values for different years that she'll be working at the business. And also it helps her to graph this function and see her salary increase. And then her growth factor, this is big. Her growth factor is 1.12 minus 1, which is 0.12, or let's convert that to a percent. It's 12%. So she's getting a 12% raise each year. Oh, here's an additional example for you to try. Look at the Johnson Company that calculates its value of its stock each year by using this function. Go ahead and identify whether it's growth or decay. Give the initial value, the growth or decay factor, and the growth or decay rate. Okay, this is the end of the video. Let's go ahead and recap this question. How do you identify the growth decay factor, the rate, and the initial value from a function? Give me an example, and you can do this for your summary of the notes. Give an example of a function, so go ahead and write a function, and then explain to me how you identify the growth or decay factor, the rate, and the initial value using that function. Bring your work to class. Don't forget about the extra credit opportunity where you bring in your own examples. And then when I ask for volunteers, you can go ahead and present your problems. Bring any questions you have to class as well.